So let's dive right in. What roles should we have in a typical machine learning project?
Okay, that is a very good question as for the beginning. The machine learning systems often relies on three key roles. This is data scientist, data engineer, and the machine learning engineers. Each of these roles is focused on distinct aspects of machine learning. While there is naturally some overlap, there are some certain critical areas where the collaboration is most noticeable. Data scientists primarily are focused on identifying various solutions for business problems. So, for instance, the task with predicting the user clicks, click-through rates, they analyze the data, identify the most appropriate algorithms for the task, and so on. So, in essence, data scientists are primarily concerned with building and testing machine learning models. They're quite often also tasked with talking with the business analytics of the clients and other stakeholders to really establish what needs to be done, what model we needs to build, and so on and so forth. However, in practice, there's often a substantial gap between the production environment and the daily work environment, also called development environment, that the data scientists work on. So to bridge this gap, we often need other roles. So this is the responsibility of machine learning engineers. So the machine learning technologies, particularly those that allow machine learning models to be trained and served in the cloud, often fall outside of the competencies of the data scientists. So the machine learning engineers comes in to rescue. So they mainly prepare the environment. This can be dev environment and the production environment. So the data scientists can work as efficient as possible. And then when the model is ready, when the model is trained, when you have all the pre-processing ready, then the machine learning engineers can take the model, put it into the production to be ready to serve predictions. And also they need, of course, to monitor the quality of the model, to monitor all the drift and so on.
Certainly, we must not forget about data engineers. They play an integral role in building systems that ingest, transform, and process the data. And the exact responsibilities, it can vary depending on what exactly they are working with, whether it's a data lake or a data warehouse. But on daily basis, they work very close with data scientists. They actually help them out with issues like data availability or data quality. And this kind of help is very often critical because that actually unblocks the data scientists. So this kind of combined efforts is ensuring the availability and quality of the data. And this is the area where the roles naturally intersect and overlap.
Okay, so let's discuss what, in my opinion, is the most important and also the most challenging part of every machine learning project. That is how to scope the requirements for the machine learning, how to define a scope.
Oh yeah, of course. We should start by asking ourselves a few critical questions, like what kind of task the model will be automating or how the user will be interacting with the model.
Okay, that's a good point. So let's assume we are challenged with the project to create an application for monitoring shelves in the shops. Okay, so we have the shelves, we have the product on the shelves, and sometimes we have the gaps. So what we need to do, we need to detect the gaps. We need to detect the product displacement. So different products are on different shelves, that what they should be, and also give the total number of products on the shelves. How would you relate this problem to the questions you mentioned?
Oh, I would start with interviewing the users. So it's critical to understand the problem from the user's point of view. And it's very important that we talk to them and that we collect as much information as possible. And by users in this case, I mean people interested in having shelves in the shop in expected form, basically people interested in planograms. And once we talk to them, we can understand what information is the most important for them, whether those are the gaps in the shelves or it's a product misplacement. And the more we understand from the user's point of view, the better product we can make. Because if we have a gap in the knowledge, if we don't talk to the users, it's likely that we'll build a product which is in some sense perfect, but doesn't really meet the requirements.
Okay, so yep, that's a good point. So to be on the same page, by perfect you mean that it's using the edge case technologies. It has great or perfect, near perfect accuracy, great performance, and so on. But it doesn't really perform the task that user intended it to perform. So it really doesn't solve the problem at hand. So, and this is because we use some rough information from the proxies, not from the end user. Yes?
Yeah, exactly. So it's not the Olympic Games. We are not aiming for some specific accuracy or recall. Our goal is to serve the business purpose.
Yep, exactly. Thank you.
Very well then. Let's talk about quantity. What factors do we have to take into account when deciding on the amount of data needed?
Yes, this is usually the very first question I hear from business owners or the business stakeholders when starting the new projects. How many data and what kind of data do we need to make this project happen? And from my experience, we should take into consideration several factors. Like, for example, how complicated is the task for the human, whether we can start with a pre-trained model and do the transfer learning or fine-tuning, or we really cannot do it and we need to start everything from scratch. How many classes of the products do we need to detect? And how similar are the classes to each other? Can we find a way to automatically augment the data and create new training instances? What accuracy do we really want to achieve? And last but not least, what is our budget for the project?
Okay, so considering the product shelf monitoring, what questions would you ask the business user in order to help the machine learning engineer to build the most successful product, most successful model?
Okay, so I would start with the questions like what kind of problems with the product do we want to eliminate? Do you want to avoid empty spaces on the shelves? Do you want to make sure that the given product is at the exact planned position? What information would be the most useful for you to eliminate them? How often do you like to get feedback? Does it have to be the real time? And are you able to truly react in the real time alert? Or maybe a few times a day would be sufficient. How can we get an initial set of products that would be supported? How can we keep up with the new products and product changes? The model needs to be adaptable, easier. Yep, that's easier said than done. How is the problem currently solved? Okay, so even if we have some gut feeling about how much data do we need, or even if we have some estimates, it's not really the best idea to wait with start of the project until we get all the data, because we can wait several weeks or months, and this time can be a bit wasted because we won't be doing anything else. It's good idea to start as soon as possible. So even start with tagging by, if we don't have dedicated team for labeling data, to label some initial data by ourselves, to train the data, to train the model on that data, to check the performance and so on. So if we add more data, we can monitor how adding more data improves accuracy. In that way, we can estimate how much more data will be useful to add to our model to get to the desired accuracy.
Yes, I totally agree. And we can even do it programmatically. So we have something called learning curves. And this is a mechanism which can tell us how adding more data can influence the accuracy of the model. So by following those curves, we can see where and when it makes sense to add more data.
Yes, and from my experience, it is also very useful to manually go through a few examples of the task we want to automate. Like, for example, to ask the end user, could you please show me what the process looks like right now? And go through a few examples of them. So this really helps us to later choose the best input data, the best features, and also the best model for the task. And that's because we have seen what's really need to be emphasized, what the user really look when they're doing the process. So probably the same features would be very useful when building the ML model.
Yeah, and I would say that it's a good idea to start sketching out a set of possible solutions. So I would not jump into the first solution, which seems to be good. I would think broadly and come up with at least a few solutions which you could present to the stakeholders. And when you present them with the pros and cons, you get the idea which of them is the most appropriate in a given scenario.
Yes, that's a very important point that you have touched upon. Machine learning, like probably every R&D project, is not a one-time task. So it's very hard to get it running on the first go. Usually, this is the iterative process where we gather set of ideas, we implement them, we test them, and if the result doesn't meet our criteria, we repeat the loop. So we gather ideas, implement, test, so on and so forth. And we continue that until we have the model or the solution that meets our criteria.
Yeah, and it's also very good to start thinking early about the metrics we would like to measure our models against. So the metrics could be the final accuracy, the latency in milliseconds, the memory usage of the model, and of course, the budget. So how much is going to cost to train our model? Because when we are training in the cloud, we can very easily run out of budget, especially if we run several training processes at the same time. And not every project supports a budget for an extensive research.
Yes, that's a good point. It's very important to keep in mind the metrics during the whole process, so we avoid having a moving target.
Moving on, what data do we need for a machine learning project?
Yes, this is usually one of the key questions we must answer when starting a new ML project, because the data lays at heart of every machine learning project, solution, models, pipeline, and so on. Ideally, we would like to have the data with natural labels, meaning we can infer the labels from the system output. So, for example, when we are predicting the click-through rates, we have the data that comes naturally from the user. So the user clicks on product, the user purchases some product, the user clicks on recommendation, and so on. And this gives us the information that this kind of user likes this item. And we can create the data set from that and have our training data built from that. So we don't need any manual labels for that. We only need to have our system running for some time, and we will get our data set prepared.
Yeah, so just the fact we are storing the information about user clicks means we already have the data ready for building the ML product in that case. So we can just feed that data into our ML pipeline and see the results.
Yes, that's true. But unfortunately, for many real life use cases and real life projects, we don't have this luxury to have natural labels for our data. So we need to firstly label our data manually, then update the labels, add new labels, so on and so forth. And this is very important to remember that the quality of the labels are very crucial for the upper bound of the performance of our projects. So our model will never be better than the data it was trained on. So if we have poor labels, also the quality of the model won't be that good.
True. And for that reason, it's very important that we document our labeling process. So we have the same standards. So we understand what exactly the data should look like. And it's very important, even if we are doing the labeling on our own for now. So it just sets the right standard, but also it improves the situation in the future when we have to onboard more people, so they understand what is expected from the data they will be producing. So what are the best practices for labeling machine learning data?
Yes, sure. But before we go to the best practices, it's good to mention that from my experience, at least 80% of the time is spent of fiddling with the data. So this can be gathering the data, cleaning the data, labeling the data, pre-processing the data, so on and so forth. And this also has associated costs because we can have some external teams that help us with that. And this is very, very important to get this right from the very beginning of the project or as early as possible.
Yes, exactly. So that's why data scientists are complaining about not really working with data science, not really working with models, but what they work on is data cleanup, data gathering, and so on. And that is why it's very important to actually have a very good guideline about how to gather the labels, but it's also necessary to have a review process. So multiple people are looking at the labels created. They can make sure that the guideline is followed, and only then we can make sure that we provide the data to the model of an expected quality.
Yes, absolutely. The more consistent is our data, the less time we spend on failed experiments. The experiments can fail from many reasons. Like, for example, the data may be inconsistent, the labels can be mixed up, the quality of the data may be not as good as expected, we may miss some labels, so on and so forth. And of course, every of those failed experiments costs us real money. This is because usually we train our models in the cloud that charge us per every minute or per every hour. So the better the data, the bigger savings in our budgets.
Yeah, and I would add on top of that that some of the things you just mentioned are kind of directly transferable to the cost of the project, but some of them are indirect benefits. So, for instance, your employees' happiness, that increases with introducing best practices and means you have much easier time of keeping them on board and recruiting new people.
I agree. Now, circling back to the best practices, it is important to remember that the person who will be preparing the guidelines should have already some familiarity with the data itself. So it will be best if she or he spends some time annotating the data so they know what are the common problems, are unclear points, weaknesses of the data, and so on.
So based on what you said, when we decide for the right tool, we have to keep in mind many factors. So what kind of data we are dealing with, the privacy of the data, the budget for the tool, whether we want to have an offline or an online solution, and also the integration with our pipeline.
Very well, Martin. Tell me, please, what hardware do we need, or what hardware would you recommend to train machine learning models?
That's an excellent question. There is a common misunderstanding suggesting that we require very expensive GPU, very expensive hardware costing tens of thousands of dollars. But in reality, it's quite possible to train your models on modest devices like your laptop. So for instance, when you are dealing with tabular data, it's very likely that a CPU will be good enough. And on top of that, even if we are dealing with computer vision, which is a problem perceived as requiring high-end GPU, there is an efficient workaround. We can start from a model which already has been pre-trained. We can reuse an existing model. And by doing that, by fine-tuning an existing model, we can not only save the money on the GPU, but that would also require less data.
Indeed, another common question that often arises is whether we should utilize cloud-based services like, for example, AWS or GCP to train our models, or instead opt out to purchase our own servers, perhaps even hosting them in our own data centers. Both of those options have their pros and cons, merits and drawbacks. For example, in the case of cloud-based solution, one of the significant advantages is their inherent flexibility. If one needs more resources or we have the new joins in our team, we can scale up easily and almost in real time. On the other hand, if we have our own server, we can host our data that can be private, that can have some restriction of sharing. So for example, this can be some medical data, some banking information, and so on. So if we have our own server in our own data center, we are sure that the data doesn't leave this data center, and we can happily use it for training our models.
Yeah, absolutely. So the scalability of the cloud services is not only about adding more hardware, but also about the ability to scale down when you don't need the resources anymore. And this kind of elasticity can significantly improve the costs, and that makes cloud solutions potentially more cost effective. So in my opinion, if your potential project privacy policy allows you to use cloud services, I would really start there. And by beginning in the cloud, you can assess your needs. You can do back of the envelope calculation and understand what exactly is needed. And after that, you can consider whether investing into your own hardware might be really worth it.
Yes, absolutely. Especially when you have multiple engineers conducting various experiments simultaneously. You would like to take the advantage of the cloud flexibility in adding and removing multiple machines, or changing the size of the machines and scaling down if we don't use them, so on and so forth. Managing these resources in the cloud environment can be more efficient and less time-consuming than introducing new machines into your own data center, which can sometimes take several days or even weeks. And there is also the point of the backup. So in the cloud environment, we can very easily configure our backups. So if something fails, we can easily roll up the backups and be done, not lost our weeks or months of works. And in the case of our own data center, this involves much more configuration, much more hassle. It's also worth to mention that often we need quite different set of hardware for the training the model and using the model in production. This is because of the varying computational needs. For example, during the model training, you want to fit as many examples as possible into GPU memory to have as big batch size as possible. However, in the case of prediction, especially in real-time prediction, our priority shifts to predicting a single example as swiftly as possible. This variance sometimes make it necessary to have two completely different set of instances of hardware or servers. Okay, so Marcin, it seems like we have prepared our data, we trained our algorithm, and we are all set to push everything into production. What are the steps we need to consider before doing that?
So there are some crucial decisions that need to be made even before the model training process begins. And these include things like accuracy expectation, memory limitation, and expected latency. And these considerations influence how we choose to train the model. But also what we need to make a decision about is whether the model will be real-time or a batch model. So real-time is interacting with the users when they come in real time. And the example would be a fraud detection, for instance. But on the other hand, the batch model can be run overnight or every hour. And this approach is much simpler. It doesn't really require any immediate interaction.
Okay, so I guess it makes sense to elaborate on why the batch prediction is simpler.
Oh yes, this approach is much simpler, both in terms of model construction and infrastructure management. So with batch, also called offline prediction, we don't need to maintain an always-on infrastructure, which can reduce the cost. And these are important considerations when building the model. But at some point, we decide to transition into production. And upon moving to production, it's critical to ensure that our model is monitored and automated. And automation should be introduced as early as possible because that minimizes the risk of errors caused by human intervention.
Yes, I agree. You should decide very early on what kind of deployment you would like to follow when we are releasing a new model.
Okay, so when it comes to deploying your model in production, it's important to keep in mind that you don't have to roll out the entire new model all at once. There are various types of deployments like canary or shadow deployments, which can mitigate all the risks related to errors introduced with the new model. So doing this kind of step-by-step approach, you can slowly evaluate the model performance and adjust if necessary.
Yes, absolutely. But also, please don't overlook the crucial step of setting up the data collection system. This accumulated data can be invaluable when training subsequent iteration of your models, or even when debugging your model. So if you see that your model made some incorrect prediction or your client complains about the quality of your model, you can look at the accumulated data and see what was the problems. As many of us know, the journey of machine learning doesn't end once the model is deployed into production. Even quite the contrary, this is just the beginning. There will always be more to learn and improve to make the cycle to follow.